Okay, so what I'm going to do, I'm going over to paper. What we need to realize is that we have maybe 2 weeks left, approximately. There's 2 chapters left, and I'm literally going to do one of the chapters today. So this chapter is chapter 8, and this is about perimeter, area, and volume. And so these are the kind of formulas that gets used in geometry, and you may or may not have to memorize them. You can put it on a note card or something if you need the formulas, but most of it actually makes sense. And so I'm going to start. 8.1 is about perimeter. Now, the first definition they give is a polygon, and a polygon. So poly means many, and gon means sides. So many sides, and the sides are straight. So an example of a polygon would look like that. So this is a rectangle. It's not perfect, but there it is. And so that's an example of a polygon. If you're going to use straight sides, the smallest you could have would be a triangle. Okay. And you could have multiple sides to a figure, you know, 4 sides, 5 sides, whatever. But perimeter is to add the outside edges. Okay. So in general, depending on what the shape is, I'm going to start with a square. Okay, I'm going to label it in case you can't tell. So here's a square, and what the square looks like is all the sides are identical in length. So if this was 5 inches, it would all be 5 inches. Okay. So the perimeter is this side plus that side plus that plus that. So the perimeter would be 5, 5, 5, 5. And the simple answer is 4 sides all identical times 5. So it's 4 multiplied by the length of one side. 4 times 5 is 20 inches. Okay. So one thing I do many times is when they have a form, one of these type things, I draw it. And drawing it helps me remember what needs to happen. Now you can memorize this crazy formula, perimeter for a square. Perimeter is 4 times the length of one side. But the truth is, once you draw it, you could just go around the edge and get it. So in a room, it could be used to figure out the baseboard, you know, the little measurement on the bottom near the floor, or something like that. If it was a larger thing, it could be used, how much fence do you need to go around the edge of a garden plot, something like that. So perimeter is outside edge. And so literally what you have to do is add up the edges. Now, let's say the next one we do is a rectangle. Now, a rectangle is a variation of the square. And so the thing about the rectangle is the opposite sides are the same length. So for instance, if this was 10 feet and you knew it was a rectangle, or you could tell by the shape of it, this opposite side would be 10 as well. So once you have one, you really have both. And let's say this was 6 feet. This opposite side is also the same as the opposite, and so that would be 6. So what you have is 10 and 6 and 10 and 6 to get the outside edge, which is the perimeter. So what we have are 2 of the 10s, and we have 2 of the 6s. Is that clear enough? Because we have, this is a match to that, and this is a match to that. And so you can use the formula without numbers or without specifics would be 2 multiplied by the length and 2 multiplied by the width. So here in this rectangle, you might call this one the length for L, and this one the width, length and width. And so this would be your basic formula. And so if you have to do it, then order of operation kicks in. 2 times 10 is 20. And 2 times 6 is 12. So perimeter in this particular one that I gave would be what, 32. And notice this is feet and this is feet. If this was feet and this was inches, you couldn't add the numbers. You'd have to make them the same. So I've said before, and this kicks in again, if you're going to add, you must have like things. So this is feet, this needs to be feet. And so that's fine. That makes 32 feet. How's that? Okay. The defining thing about a rectangle is that each of the corners makes a 90-degree angle. And this is sometimes the little symbol to say it's 90 degrees. It's perpendicular. This is perpendicular to that. And so that's sometimes you'll see this. If not, you'll see it eventually, okay? So this is a rectangle. Now they take this rectangle, okay? There's a rectangle, and they're going to pretend that the sides can move, and we're going to push the top part over. This is now called a parallelogram. Now, do you have to memorize every last word? No, but can you tell that by pushing this top over, we ended up with this shape? Now, interestingly enough, because it was almost like there were connections here. If this was 10, this would be 10. In other words, the length of the top and the bottom didn't change, they just got pushed. And if this was 6, this would be 6. So a parallelogram is just a version of this that's moved over. And so when you add up the sides, well, you'd still have 2 10s and you'd still have 2 6s. So the perimeter would be 32, and let's say it was still in feet, then you go feet. Okay, so that's a parallelogram. So it's no big deal. It's just a version of this. And so the structure didn't change. In other words, this and this still stayed the same length as long as the 2 uprights. So the last one they talk about is, what if you had a triangle? Now, if you wanted the perimeter, and they use P for perimeter, then all 3 sides could be different. And so if this was 3, and this was 4, and this was 5, all you do is march around the outside edge and add them up. So it'd be a 3 and a 4 and a 5. And let's say it was yards or something, I don't care. And so that would be 7 and 5, that would be 12 yards. So clearly that would be, it's really, we're talking about a fence. going around the edge. In a room, it's going around the edge, and so on. So perimeter, once you realize there's several things that happen with perimeter. One, it's just a matter of looking at the picture and adding up the sides. And in some cases, you have duplicate sides like this one I talked about, where the top and the bottom are the same. And in this case, there's duplicate sides, but in the triangle, it's possible to have all sides different. And so just add up all the sides and you're in good shape. The other thing is the unit, the word, feet or yards or meters or inches or whatever it happens to be. It's all just a plain unit. In other words, when I had 20 feet and 12 feet, I got 32 for number, and feet, and another feet still makes feet. Okay, so it's always just plain feet, because we're going to have square feet and we're going to have cubic feet eventually, but not yet. Now, the one interesting one is, what if they said, here's a circle. Well, it's sort of a circle. And I'm going to start here. Can you tell the distance around? Now, somebody once gave me a phone call. Okay, this is a true story. They were going to a lighthouse. I mean this is in Maine. It was on an island. And the lighthouse, what they were going to do is put a small little fence around the edge. They didn't, so they had to get into a boat. They had to, take the correct amount of fencing, because if they didn't get it right and they didn't have enough, they had to get in the boat, go back to the mainland, go to the store, get the right amount, and then come back. And it was quite a trip. So they wanted to get it right the first time. So they called me. They said, how much fence do we need? And I said, do you know the diameter? Well, diameter is the distance from one edge to the other going through the center. So you could have smaller numbers, but this is the longest length in a circle. And so it goes through the center. And so this is called the diameter. You see this in dishes, a dinner plate is 10 inches diameter. A smaller plate might be 6 inches in diameter. And so that's how you see it advertised. And so diameter is this length. Now, can you figure out, if you knew the diameter, and I can't remember what it was, but let's say it was 10 feet, just because I like that number. Can you calculate the distance around the edge? Now, instead of calling it perimeter, they have a different word for it, circumference. So circumference is the distance around the circle. Now, it's not like you can take a tape measure and measure and measure and measure. So I always take what's handy. And what's handy for me is my purse. Why? Because it has a strap that bends. And so here we go. I'm going to take from here to there. That is the diameter. Everybody clear about that? See where I am? So that's the diameter. Now, the reason I picked my purse is because I can bend it. So I'm going to go around the circle, and let me see if I can mark it. So the first mark was about there. Okay. Let me see if I can get this right. So the next mark was around, let's see, there. Okay. So I measured that one. I measured what's that one. And the question is, how much more is it gonna be? Huh, this one. It's right around there. When they first tried to calculate this, and this is way back, centuries, they said, my goodness, it looks like 3 times. So if this was 10, then it looks like this was the first measurement, so that would be the first 10. This was the second measurement, and I know I did it kind of sloppy, but that would be another 10, that's 20. And this would be the third one. And so they said, oh, it's about 3 times. So we're talking about 30. If that person in the boat took 30 feet, would they completely cover this circle?
No.
Not quite. But can you see why they were, when their measurements weren't perfect, that they would say just 3? Can you see why they'd say, oh, it's just 3? But 3 is not quite right. It's 3 plus a little bit more. How much little bit more?
0.14.
Yes. They realized that every circle, no matter if it's small or large or huge, every circle, when they knew the diameter, they knew how many times it went around. And it's all very similar. So,
So that's where pi come from?
yeah. This is as much as I memorized. This number does not stop. So remember when we were dividing out decimals and it would eventually stop, and then we'd say, oh, that's great, I'm tired of dividing. This number does not stop. So it goes on and on and on without a pattern. This is called irrational. I don't know if you like that word, but I do. We have a right to be irrational, right? If we feel like it. This is mathematically called an irrational number that goes out forever, so there's no way to get it perfect. On the other hand, many times they will round it to this number here because that's probably good enough to calculate. And you could still add a little bit just to be safe because we don't want to make this trip twice. And so literally, if you take 3.14 and multiply it by 10, and they use capital C for circumference. When you multiply by 10, remember what we've done this before, multiplying by 10 is a decimal shift, 1 decimal place. And so this is why I picked this problem, by the way. So I move it over 1. And so the circumference would be 31.4, and what that would be in feet, because the original was in feet. Okay. So of course, to make the trip, if this was a correct number, I would round that up a little bit, but with 3.14, this is my exact answer. Does this make sense?
Very.
This is a very interesting number. And so at our school, we had Pi Day. So pi is a Greek letter, and they nicknamed this number because it comes up in mathematics a lot. It comes up every time you have a circle in all kinds of formulas. We'll see it later on, but it's one of those numbers that come up almost, it seems like, out of the woodwork, and there it is. And sometimes they'll call it a universal constant. It's a number that appears. In some cases, you may have seen science fiction stories where they would send out this number and look, hopefully there was an intelligent being somewhere out there in space. Because this is a number that would be recognized. This number is important, and it keeps coming up over and over again. There are other numbers like this. but this is the one most people are aware of. So Pi Day is actually March 14th. So they celebrate pi. We did
Yeah, there's a movie about
artwork
it.
and we made t-shirts.
There is a
It's so
movie about it.
interesting, yeah. But that's, I just wanted to tell you that. So, you know, you can be geeky with math, if you're so inclined. So the formula, circumference, this is the Greek letter pi. And so you've probably seen that. So if you take 3.14 for this number and multiply it by the diameter, you have the formula. Now remember, the diameter is the distance all the way across. So this is the diameter.
Okay.
If you only had the half of it, now this is where it gets interesting. If you had a circle and you had the center, but you only had this much, this was the measurement. This measurement is called the radius. And sometimes you see this word, the radius arm of something that's rotating. That's the radius. It's from the center to the outside. Notice it would be the same no matter where you measured it, because this is supposed to be a nice, beautiful circle. So if you've measured it from here to here, it would be the same number. So if this is 5, the distance here would be 5. So let's say the radius is 5 feet. If you use the formula, you don't put 5 in here, right? Because you only have half of the diameter. But here's the other part. If this is 5, this is 5. Or the circle is not a good circle. It's misshapen. It's not really a circle. And so the radius, so this is why we need pictures, because if you had the radius from the center out, that's 5, this would have to be 5. And so the diameter would have to be 10. You see it? Okay. Now there is another version of this formula. I kind of like this one, but there's another version that somebody might have learned. 2 times pi times the radius. Well, with this picture, it's 2 times 3.14. I'm going to use that as my approximate number. And the radius is 5. So really, if you put these two together, 2 of the 5s make 10. So it ends up being 10 times 3.14, which is 31.4. Is that okay? So this is the other version of the formula. If somebody is now they're remembering 2 pi r, then it was because it was this version of the formula. This is also would work, but you need the diameter. This, you need the radius, but the formula forces you to double it to get the diameter. Okay?
So when you multiply, you jump the pi and you just put,
Yeah, I would, I mean, in this particular case, because I knew 2 times 5 is 10,
okay,
and because I can, with multiplication, remember the commutative and the associative
yeah,
property, you can multiply them out of order,
okay,
making life simpler. That's why we considered looking at that. And so 2 times 5 is 10. I did it because it's a lot easier.
gotcha.
Got it. Okay. I'm into, you know, a lot easier. What do you think about that? So really, what we had was we had a square, we had a rectangle, we had a parallelogram, which is just the tipped over version of this. We had a triangle, and finally we had the circle. So all of these with the straight edges, they called it perimeter. With this one, it's the same thing, but it's around a curved surface. They call it circumference. So you might have heard circumnavigating the world. You're trying to go around the world. Circumnavigating, circumference. Okay. So that seems reasonable enough. Now, in terms of dimensions, these are all one dimension. In other words, the final answer will be in feet, miles, inches, meters, whatever. It will be just like that. When we go to 2 dimensions, we go to area. And when they say area, and I'm trying to help you remember the difference between the two. If you wanted an area rug, let's say you want an area rug. I do, right? You're not going to just put it around the edge of the room. You're going to put it on the floor. And so let's see what that looks like. So let's say this was 3 feet. 1, 2, 3, 4. Let's say this was 4 feet. You're trying to cover the floor. So this is 3 by 4. The question is, how many square feet, which literally means how many squares, and if I'd drawn this beautifully, it would have been so much nicer. But how many squares are there? 4 times 3 is 12. Area equals the length multiplied by the width. That's the formula. It's easy enough. Area equals, let's go 4 feet multiplied by 3 feet. Okay, the number part is easy. 4 times 3 is 12, plus you could count them if you felt like it. But here's the interesting part. Feet times feet is not feet. Feet times feet is square feet. In other words, we're talking squares. So if these were little tiles or something, it would take 12 of them. 12 squares. And literally, you multiply the number and then you multiply the words. And feet times feet is square feet. So there's 2 ways you might see this square feet. This would have been abbreviation of square. Okay. But another way, since we know about squaring, you could also see it like that. This is a little bit quicker to write. You probably would say square feet and not feet squared. 12 square feet, 12 square feet, 12 square feet. You'd probably say the same thing because it's the easiest one to say. But these are different ways you might see it actually explained or written out. Okay. So now we're not talking about the edge. We're talking about this part of the picture. And so it's area. And everything that's area will be square something, square feet, square yards, square inches, square miles, whatever the unit is, this and this need to match, and then it's square, right? Remember when we did 5 times 5, we said that was 5 squared. right? Feet times feet is
Okay.
square feet. So the words work like the numbers did. And so, and literally that's what we're trying to accomplish. Square feet, how many square feet? So where are you interested in square feet? Well, if you're interested in rugs, that would help. If you're trying to replace a floor, you need to know how many square feet. If you're going to paint, I've done all these projects or hired somebody to do them or talked my son into doing them or whatever. Painting, square feet so that you order enough paint. How many square feet are you trying to cover? And so this is important and practical. And so literally, if it's a rectangle, and lots of things are rectangles, it's the length times the width. And then just be sure and call it square something, whatever it happens to be. If it was a square itself, let's say this was 3 meters. A meter, we haven't talked about it, but a meter is a little bit more than a yard. And so a meter is a length. Then this would be 3 meters. The area would be 3 meters multiplied by 3 meters. In other words, the length times the width. It just happens that they're the same number because it's a square. So then the number part is 3 times 3, which is 9. Okay. The unit, meter times meter, would be square meters. One way or the other, it would be like that. So these two are connected. If it's a square, same thing as the rectangle, same formula, the length times the width. Remember, this is the parallelogram. It has the parallel because this is parallel to that. This one, although it's sloped, is parallel to that. So that's the name for parallelogram. Now, this is just a version of the rectangle. So what I'm going to do is I'm going to draw a line here. And see this little triangle in the corner? This one? If I picked it up and placed it over here, in other words, I moved it from here to here. What do I have now? What is this?
Square.
It,
I mean,
rectangle. Yeah, it's definitely a rectangle. So this piece and this triangle and this triangle are equal in area. And so when you pick this up and put it over here, you're talking about a rectangle. And a rectangle is something we know how to deal with. So for instance, if this measurement was 12, let's say 12 feet, that would be the length. And so either you take this away and put it over here, you still have 12. The slanted line is not the one we need. The one we need is this one right here. This is the one that's perpendicular to this base. And so it's this measurement multiplied by this one. Typically, they call it the height. And so they would probably call this the base. They would probably call this the height. When they use the word height, the implication is that it's perpendicular to the base. But it's really, it's trying to make this into what amounts to a rectangle. So let's say the height, which is this dotted line, is 5 feet. What I've basically done is made something that's 12 by 5. Area is the base times the height, which is really the length times the width. Can you see it visually?
Mm.
12. And then what you need is the vertical. And so this is going to be something we're not, the only time we'd be interested in the sloped one would be if it were doing perimeter, but we're not, we're doing area. So we're interested in the height. So we're talking 12 feet multiplied by 5 feet. Does anybody know that straight off?
120?
No, that's too
No,
much.
110,
Too much.
just 60.
60 it is. 60. And feet times feet. This is multiplied
Where?
square feet. Okay? So visually, now you can write down every one of these formulas, but so far, we've really only talked about 2 things. Visually, perimeter going around the edge, which means you just add up all the sides, or area, where it was basically amounting to a length by a width. And in this particular case, you needed to pick up the height instead of the slanted line. Now what? Okay. What I have here is a triangle. Right? I want the area. This is not a rectangle, is it? But I wanted to visually show you something.
Mm,
I did a pretty good job up there. The triangle itself is what fractional part of the rectangle?
half.
Half. That's the formula. So instead of what we were just doing with triangles, we're dealing with half. And so that's the formula. Visually, I think it looks like half, and it is half. Okay. So what do we have? We have this side here, which is the base, right? We have this measurement here, which is the height. So this, getting this perpendicular measurement is what we need. But do we just multiply the base number by the height? That's
Twice?
too much. That would be all of it.
Oh,
Nope, we need to half it. Here's the formula. Area equals 1/2 times the base times the height. And usually they'll abbreviate it 1/2 times the base times the height. When we go into geometry, go into a different side of the brain. This is so interesting to me because some people, one side works better than the other side. This is visual in a lot of ways, although we're going to use formulas to actually get the answer. I think visually it shows what's going on. They didn't just dream it up and make up something that didn't make sense. This makes sense. Somebody had to figure it out initially. So let's say this base number, let's say this measurement is 12 inches. Okay. And we need this vertical height. Let's say this is 4 inches. So they might draw it for you like that. If they tell you this length and that length, that nobody cares. These are the only two measurements that we need for our formula. So it would be area equals 1/2 multiplied by the base, which is 12 inches, multiplied by the height. Height is perpendicular to the base, 4 inches. Okay. So area equals 1/2 times 12 times 4. And you can put this over 1 over 1. I think I'd cancel. 2 into 12 is 6. 6 times 4 is 24, right? 2, so this is why we learned our fractions. 2 into 12 is 6. 6 times 4 is 24. Inches times inches is square inches. So notice the use of the half because it's a triangle. And if it's a triangle, it's only half. Is that working for you?
Nice.
Yeah, it definitely makes sense. Okay, so we did all the things, but guess what we didn't do yet?
Cylinder.
Well, we got to do this first.
Oh.
Area of the circle. We have to make these into squares. You know, remember we did this here? The triangle, we did it into square. How many square units? In this one, we did it how many square meters? And how do I make a square out of a circle? Are you ready for this? I saw this demonstrated in Boston at the Science Museum, and I thought, boy, this is good. What they did was they had a circular disc that was flat, covered with sand. And so all the sand fit in this. And what they did was they had it so that you could shift it. And here's what happened. There was a second set of things. So originally the sand was inside the circle, but you had the ability to tip it. And so some of the sand would go into the corners. And what they were trying to do is say, how many of these squares could fit? And so what I'm going to do is I'm going to take, visually, I'm going to take some sand from this corner, okay, and put it here. It was very clear to me that we could fill at least one square by taking some of the sand when I tipped it and filling this. Do you see what I'm saying? We could tip it and that would be one. In fact, using this as our leftovers, I'm going to take some more of this and I'm going to fill this one in. So when I tipped it, I could fill this whole square and this whole square. The question is, can I even fill this one, a little corner here? Yes, I have enough sand. And I'm going to fill this one. The question is, so when I tipped it, I could fill this 1 square, 2 squares, 3 squares. Did I have any sand left over? I did. You see where this is going?
Right.
I have 3 full squares with a little bit left over.
0.14 left.
Exactly. This is the pi coming back to us. And so it was so fun because you could literally do it and see how many squares you could get. Area equals pi, which is how many of these squares we're going to get. How many full squares? Clearly 3 with a little bit left over, multiplied by the radius, and this was the radius, squared. So this here is a square radius. This one. That's a square radius. I turned a circle into a square. And I had enough for the second one and enough for a third one. And I had a tiny bit left over. Area equals 3.14 multiplied by the square radius. And so this has to cover, we have to cover this. And that's a square radius. And this is that's the formula. This science museum in Boston had all kinds of things where you could see formulas developing, where it was meant in some ways for children as well as adults, so that they could literally do this and see how things came about.
Nice.
You know,
That's
I
where
was
MIT is.
impressed. Huh?
That's where MIT is.
Yeah, exactly. Yeah. So anyway. So it's kind of strange, but they figured it out, and doggone if it wasn't pi again. And you can pretty much count on if it has to do with a circle, it has to do with pi. And pi comes up in other formulas too, not just circles, but all kinds of things. It's a lovely number. And they keep figuring out, well, now I've figured it out to 100 decimal places.
Oh,
And they use computers and try to figure it out more. And somebody figures it out to 1,000 decimal places, and they keep going and going. There's no pattern. It's very clear there's no pattern. It's not going to happen.
you think it's infinite?
It is. It goes out to infinity, always without a pattern. Fascinating number. So, but this is your formula. So I hope that kind of did it for you. I don't know. It did it for me, but I don't know. Let's find out. So the formula requires the radius. And so the radius, let's say the radius, I'm going to use 10 again because it's easy to do without a calculator. So if the radius was 10 feet, the radius is from here to here, that's the radius. If we wanted the area, and you don't have to memorize this, but it does actually make sense, pi multiplied by the radius squared. Most of the time they say use 3.14. So we say, okay. Why? Because that's a fairly good approximation. So pi replaced with this, notice that's a rounded number. It's not perfect. Then the radius would be 10 feet. And the square belongs on the outside. So in order of operation, the squaring is done first. So 10
100.
feet times 10 feet is 100. And feet times feet is square feet. Okay, and why did I use this? Because I
350.
wanted numbers that I didn't have to pull out my calculator, although it's handy on the desk. So 3.14 times 100, one place, two places, area is 314 square feet. Okay, so if these numbers get ugly, then they're either going to offer you a calculator or you should use one. Right? Because I picked the nicest number I could think of. But not all numbers are so nice. All right. So you do the square, you do the radius, make sure it's the radius. The radius is squared. That's first, and then you multiply it by 3.14. How's that?
Also,
Okay.
I like how you explain things.
Oh, good. So the third section is skipped. It's about surface area, but the fourth section is volume. Now, volume is three-dimensional. So I'm going to start with my rectangle again, because that's a good place as any to start. And so I draw it like that, and then I connect. If you're a better drawer than me, but that's an easy way to draw. So volume has to do with how much is inside. So it really has to do with what was the area, and then there's this last measurement. How tall is it? So this is the length. This is the width. So the length times the width, when you ignore that, is just area. But then when you go into volume, you have height. The simple formula for this rectangular box, and it's like a box, volume equals length times width times height. So let's say this was 5 inches, 4 inches, 3 inches. The formula would just, you place the numbers in, 5 inches, 4 inches, and 3 inches. 5 times 4 times 3, this is 20, 20 times 3 is 60. That's the number part. Inch, inch, inch. What is it?
You,
Inch times inch times inch. If it was 2 of them, it would be square inch. If it's 3 of them, what is it?
third power.
It's cubic inches.
Huh.
So you may have cubic inches, which could also be written as cube 3. This is three-dimensional. It's 2 dimensions and then another dimension, which is height. This is three-dimensional. If you think back, the perimeter was 1 dimension because everything turned out to be a plane unit. Area was always square, square feet, square yards, square inches. But volume is always cubic. Okay, so if we did this times this, it would be 20 blocks. But then when you go 3 high, it's 60. And so that's a simple formula, but that's definitely a formula. So sometimes when you try to ship a package, they'll measure it. Have you ever seen them do that? Where they measure it to see how much they're going to charge you. You know what I'm saying? Have you seen them do it? They're looking for the volume, and they're going to charge you based on that. Yeah. You don't have to memorize any of these formulas, but somebody mentioned earlier a cylinder. That's my best bet. This is a cylinder. If you notice what we've got under here, you've got a circle. The formula for the volume, and so this is a can of soup or something like that. The formula is made up of 2 parts. What's the what was this formula for the bottom part, which is the circle? No, I can't do that. It was pi r squared. That was this part, multiplied by how high it is, which is height. So it really is the formula for this multiplied by how tall it is. That's your formula. Again, I think you'd want a calculator to do it. There's two other interesting ones. So that's that. I want you to guess. This is so interesting to me. A cone. This is shown. This is just sort of, ignore it or not. But let's say you took this cylinder and then you turned it into a cone. This goes away, this goes away. How much of this full thing do you think you have when you make it a cone? You've taken away all of that. Do you have half of it left?
That would be my guess.
That would be my first guess, but it's not a half because this is going down to nothing right here. So at the top, it really is like nothing or, next to nothing. The bottom, it's a full cylinder. It's actually ends up being a third. Multiplied by pi r squared h. Okay, I would have guessed a half. Because a cone, they have a couple of questions where they're trying to fill a cone, like for, if you turn this upside down, like for ice cream, that's the cone.
So you have numbers, how you multiply it?
So you would use pi 3.14. You would have to be given the radius.
Hmm.
You'd have to be given the height. In other words, to use a formula, they have to give you all but one number. And they wanted to know the volume of a cone. Okay. And so the 1/3 is given. This is known. They'd have to give you the radius and they'd have to give you the height.
All right.
Okay. So I know the time is almost up and but this is directly coming from that. And so what I'd like you to do is work on chapter 8. So I've shown you all the formulas. And so, but my real suggestion is to, if there's a picture, draw it, label it, and then look up the formula. How would that be? Or if what I did made sense, then maybe you could actually, in a lot of cases, figure it out based on the picture. Okay. And if the numbers get ugly, just pull out a calculator. I don't care.
Mhm.
Yeah. Okay. So any questions? So I think this is technically due Friday. So see what you can do. Send me questions if you run into anything. There's a few weird ones at the end, but I, kind of ignore them, but just go work through these basic formulas. Most of these are practical. We're doing remodeling in this house and there's like, oh, walls, rectangles. I got rectangles, I've got squares, I've got a slope ceiling, I got all kinds of things and they all require some formula, right? Unfortunately, I don't have to do the work. I just have to help calculate it. Okay,
You're the engineer.
huh? Yeah,
You're the engineer,
yeah, that's right.
architect.
Okay, so are we good? Anybody, if you have questions or need to talk to me individually, stay. Otherwise, I'm going to stop the recording.
Thank you.
Thank you.
Thank you.